Always start by pre-reading your lab. You'll find that there are pre-lab questions to do, and you should attempt to do those after you've read through the entire lab. The next thing you can do is take a look at the apparatus and materials list and find those objects in your lab kit. For A part of the procedure, you're going to be figuring out the density of rubber using Archimedes' principle, which is how much water is displaced by an irregularly shaped object. That's going to be the volume. You have your scale to record the mass of each of the rubber stoppers. The rubber stoppers are different size, but they're made of the same material. So you have your procedures to read through, and then in a couple pages, you have your observations chart that you're going to fill out. So with this one, you're going to put a little bit of water in your graduated cylinder and record the initial volume. And then you're going to mass and add one of the rubber stoppers and figure out the secondary reading. And you're going to repeat that procedure for the 3 rubber stoppers and then calculate their densities and then their average densities. When you're taking a measurement, you want to read from the bottom of the meniscus. Water likes to climb the glass cylinder, and so the accurate reading is at the bottom of that kind of shadow line or the meniscus. Also, when you're recording, you want to record with the correct level of precision. So for sig figs, these graduated cylinders are marked to the nearest milliliter. You're going to be able to guess the last digit or record to 1 decimal place or a tenth of a milliliter. That last number is going to be estimated by you. Once you've completed all of the observations or generating all the data for part A, then you're ready to move on to the analysis of part A. You can leave this till the end, but I thought I'd put this in the video just to make sure you were supported in what you're going to do with these numbers now. So on page 7, there is another chart for you to fill out, and this is where you can summarize the key pieces of information, chiefly the volume and the mass of the rubber stoppers, and that's how you can calculate the density of each one. The first part on that page is showing a sample calculation. There's no need to show all of your math, but it is good to show one sample calculation for your data. The last part for A is to figure out the average density of rubber. So to calculate an average, you're going to add what you have together and divide by how many pieces of data there were. So in this case, 3 to figure out the average of your density of your rubber stoppers. Part B, we're going to calculate the density of glass and then compare that to the known density of glass. So you have a glass rod in your kit and you're going to weigh that glass rod on your scale. Then you're going to use your ruler and you're going to use the millimeter marked side to carefully measure the diameter and the length of that glass rod. You're going to record these numbers on the next page with your observations in that table for part B. Sorry, wrong one. So you need the mass, you need the length in centimeters, and the diameter in centimeters. Now you're going to record that in millimeters, and you're then going to have to convert that to centimeters. After you're done those observations for part B, then you can move on to the analysis of part B. So part B has you calculate the volume of the glass rod in centimeters cubed, because centimeters cubed are the units that we want for our volumes. So you're going to have to take your diameter and divide it by 2 to calculate your radius and sub that into the equation to calculate volume. So that's pi, and you can use the pi button on your calculator, times the radius squared, so the radius times itself, times the length. You can calculate the volume of your glass rod in that way. If you know the mass of it, then you can calculate the density. The next part is to calculate the accuracy of your number. So we have an equation here that is for percent error. You're going to take the difference between your number and the accepted theoretical value and divide that by the theoretical value. Multiply that by 100 and that tells you how good or bad you are. On my key you can notice mine wasn't particularly good. And answer the questions to complete part B. For part D, you're going to calculate the density of water at a specific temperature and compare your experimental values to theoretical values. So this one's pretty straightforward. You're going to need the graduated cylinder, thermometer, a pipette to adjust the level because you're going to put exactly 50 mils in, and you're going to use the scale to weigh or mass your water sample. After you've recorded your values in table 1 part C, then you're going to be able to calculate your values. So in the analysis section for part C, you're going to calculate the density of water. The mass is going to be the difference in mass between the empty and the full graduated cylinder. You're again going to use that equation to calculate your percent error. There is a chart in your lab that tells the theoretical value of density of value of the density of water at different temperatures. So it really depends on how warm your room is, and you're going to compare your experimental to your theoretical values. Part D, or the last part of the lab, you're going to continue on with some of the materials you have from Part C. You're going to continue on with your graduated cylinder with that 50 mils of water, and you're going to need the scale and a beaker again. What you're going to do is use the experimental density that you found in Part C to make a prediction. You do a calculation on a volume of water. Then you're going to compare that to an actual measured volume of water to see how accurate you are on that. So in this one, you're going to follow the procedure in Part D and fill out your observation table in Part D. And then you're going to complete the analysis of Part D, where you're going to take that literature value of density of water and the mass that you determine and calculate the volume. Then you're going to measure the actual volume of water and compare those two values. They either are or are not going to match. And if they don't match, or if they didn't match, you can see on mine didn't, potentially explain why they didn't match. After you're done that, you can clean everything up. The lab kit is yours for the semester, so make sure you put things away carefully and dry. The last part of the lab is to complete the conclusion, and the conclusion gives you a bit of a guide. So the key parts of the conclusion, or any conclusion, would be to reflect on the objectives of the lab, and you can even look back on those. And you want to summarize any key findings. There are a few questions there that kind of make this section a little bit big, so I had sort of said, let's just summarize the key findings. You can think of other things like that are in the background and theory section. And then the last part of your conclusion is to consider any sources of error that might contribute to this lab. There were several points in the lab that we did calculate error, and so coming up with some reasons for that, and not just you being messy or sloppy, are good to kind of come up with. If you need a bit more space, you can always use the back of the page. And that concludes your first lab. So clean things up and let me know if you have any questions.